Well, good evening and a warm welcome to the latest in our Meet the Experts webinars for 2024. My name is Julia Priestley and I'm one of the joint CEOs of the BTF. Today's webinar is a very special event that we're using to mark European Hormone Day, which was celebrated around Europe on the 24th of April. This is now an annual event, and the purpose of which is to put the spotlight on endocrine health and increase awareness of the importance of good hormone health. And one of the themes this year has been endocrine disrupting chemicals, which we read about and hear about increasingly in our daily lives. As patients and members of the public, it's very hard for us not to be overwhelmed and even frightened when we hear much of what we hear about endocrine disrupting chemicals. And I'm sure that for many people, EDCs are contributing to the creeping health anxiety that many people are experiencing. And so I'm really delighted that we're able to hold this webinar today and bring to you some of the leading international experts in thyroid and hormone health and science, and to share who can share their understanding with us. So without any more from me, I'm delighted to hand over to one of the trustees of the British Thyroid Foundation, Professor Marion Ludgate, who's going to chair our meeting. Marion is a retired research scientist in molecular endocrinology. Her career has been dedicated to the investigation of all aspects of the thyroid gland and to a range of thyroid disorders and accompanying conditions, including thyroid eye disease. And over this time, Marion has worked in research centres in Cardiff and Brussels. And she's been involved in projects funded by our own BTF Research Award, and she continues to be involved in thyroid research. So over to you, Marion. Thank you very much.
Thank you very much indeed, Julia, and it's really a pleasure to be part of this webinar. And as Julia has said, the webinar is really going to be talking about endocrine disruptors. And most of you will be aware that this can affect any aspect of the endocrine system. But today we're going to be hearing specifically about the effects on the thyroid gland. So as I'm chairing it, I would just like to make a couple of points. You will notice that there is a question and answer section at the bottom of your screen. So if you would like to put questions into the Q&A, we will try to address them, or more likely, Elizabeth will try to address them at the end. I would just like to remind you that these need to be general questions. It's not an opportunity to ask specific questions about your own health. So I'm now going to hand over to Professor John Lazarus, and he's going to introduce our speaker. John, over to you.
Thank you, Marion. It's a pleasure and honor to introduce Dr. Elizabeth Pierce, Professor of Medicine at Boston University, United States, to participate in this session of the BTF. Elizabeth graduated in medicine from Harvard and also has a master's degree from Boston University School of Public Health. She has worked at the Boston University and was president of the American Thyroid Association in 2018 to 2019. In addition, she has served for many years on the Iodine Global Network, where she is the regional coordinator for North America. Her research interests, many of which were stimulated by the late Dr. Louis Braverman, include thyroid function in pregnancy, iodine nutrition, and thyroidal effects of endocrine disruptors. So welcome, Elizabeth, to this event, and we're looking forward to hearing your talk.
Thank you. It's a real pleasure. Give me just a moment. I'm going to share my screen. All right. So pleasure to be with everyone this evening. Thank you so much for the invitation to be with all of you. And what I'd like to do over the next 30 minutes or so is to start by just a general, I'll share my disclosures, start with a general overview of endocrine disruption, what some of the key disruptors are that we're aware of, what are their mechanisms in general, and then hone in a little bit on what we know about environmental contaminants that may specifically affect the thyroid. I'm then going to talk a little bit specifically about PFAS, one group of chemicals, what we know about their effects on thyroid function, what we know about current regulations, some of the recent updates there. And then hopefully we'll try and tie this all together, thinking about what we do and what we don't know at this point, and what are the implications clinically in terms of science that's needed in terms of policy. So just to start with, this is a fairly new field. This whole concept of environmental contamination causing adverse health effects really started in the 1960s. A seminal moment was the publication of the book Silent Spring in 1962. The term endocrine disruptor was first introduced in 1991, and in 2002, the World Health Organization published its initial assessment of the state of the science in this field. And the number of publications in this area really has been growing exponentially over the last couple of decades. So though it's a new science, it's a very rapidly growing one. WHO defines endocrine disrupting compounds quite broadly. So these are any substances or mixtures of substances that can alter the function of the endocrine system, thereby causing adverse health effects in individuals or in populations, or sometimes in the offspring or for future generations of those who are initially exposed. And we are all exposed, really, no matter where we live, to endocrine disrupting chemicals through a whole variety of sources. So some of these exposures are through agricultural chemicals. So pesticides, for example, or things that are added to foods, or things that are in packaging materials that can actually leach into the foods that we eat. So examples of these include various pesticides, the PFAS chemicals, which I'll talk about some more, phthalates and bisphenols. Now, industrial activity can introduce endocrine disruption through a variety of mechanisms. One is through air pollution, and there's an increasing understanding that air pollution that we inhale may actually affect endocrine systems, but there may also be contamination of soils or groundwater, and therefore drinking water as a result of industrial activity. So examples in addition to air pollution might include dioxins or fracking fluids or some toxic metals. Then we are all sort of guilty of bringing these things into our own environments. There are a lot of endocrine disruptors in chemicals that we use as personal care products or cleaning supplies. They are found quite widely in flame retardants and in all kinds of industrial solvents and coatings. So some examples of these chemicals are phthalates, which are plasticizers, bisphenols, lots of different types of fragrances, PFAS again, triclosan, which is found in things like toothpaste and antimicrobial hand washes, PBDEs, which are flame retardants, and parabens. And then finally, as a medical profession, we are sort of responsible for introducing exposure to some of these as well. So if you think about all the plastic that we encounter in hospitals and medical care, there's a really good reason to use that. We need things that are going to be sterile, but that winds up meaning exposure to a lot of plastics and IV tubing, IV bags, all kinds of medical devices that may introduce exposure to some of these endocrine disrupting chemicals. And something that's really notable about the endocrine disruptors as a group is that they have a wide variety of different mechanisms, and they can affect any of the endocrine systems. So they may act at the level of synthesis of hormones. They may prevent production of hormones in the body. They may alter hormone transport in the bloodstream. They may alter metabolism, so increase or decrease the rate of breakdown of hormones in the body. They may also alter transport into cells that are responsive to hormones. And they, for many endocrine disruptors, it's been described that they may turn on or turn off the receptors. So all hormones work through a system where the hormone binds to a receptor in a cell that can be activated or inactivated by exposure. And some of these disruptors can either turn on or turn off receptors for these hormones, regardless of sort of the presence or absence of the hormone themselves. And then finally, ultimately, the end results of hormones are to turn on and off genetic changes and alter signal transduction. So some of these may have the potential for epigenetic alterations, which could alter health consequences, again, not just for the individual who's exposed, but potentially for future generations. No, this gets complicated because the effects of these exposures are going to differ by life stage. And there are all kinds of other potential risk factors that may interact with these exposures to have their ultimate outcomes on human health. So socioeconomic status, other environmental features, nutrition, diet, education, all of those things can impact and potentially mitigate or worsen the effects of these disruptors. When we think across the lifespan, we often, at least I as a thyroidologist, often focus most on concern about effects in the pregnancy setting. And we know that endocrine disrupting chemicals may have adverse outcomes associated with pregnancy itself. So they may increase likelihood of preterm delivery, of babies born either small or large for gestational age. They may increase risk for birth defects. They may have reproductive effects, sort of decreasing the likelihood of fertility in the first place, or perhaps altering sex ratio of offspring. And because a lot of genes are programmed in the fetus that are going to be expressed throughout the whole lifespan, there may be long-term consequences for exposures in the fetal life before birth that can have adverse effects throughout the lifespan, including on reproduction, on cardiometabolic risk, on the likelihood of obesity or hyperlipidemia. And in particular, again, when I think about related to thyroid hormone, these may have effects on brain development in early life, which could increase the likelihood for adverse neurobehavioral outcomes like attention deficit hyperactivity disorder or autism spectrum disorder, and may also lower IQ. Now, it's hard to put sort of a dollar amount on the costs associated with these kinds of exposures, but that doesn't mean people haven't tried. This is a paper published in 2016 that looked just at US costs on an annual basis of exposure to the sort of all of these endocrine disrupting chemicals as a group. And the price tag they put on this in terms of health consequences was $340 billion on an annual basis. Now, by definition, these kinds of estimates are fairly imprecise, but I think it's important to note that the biggest driver of cost in this analysis was the effects on brain development, on the likelihood of attention deficit hyperactivity disorder, or on IQ, because impairment in brain function throughout the lifespan will have huge deleterious effects, not just on individuals, but really on whole societies and on whole economies. Now, focusing a little bit more, and bear with me, the slide is a little bit busy, but I want to walk through this a little bit. These are what we know about some of the sort of best studied chemicals that we know specifically may alter the thyroid hormone axis. And there are a number of chemicals that act directly in the thyroid. So some of them inhibit sodium iodide transporter. That's the transporter that allows the thyroid to bring iodine in from the bloodstream, and iodine is needed to build thyroid hormone. So some of these chemicals are perchlorate, which is found in a lot of water supplies, thiocyanate, which is a metabolite of cigarette smoke, but also sort of oddly found in green leafy vegetables, PFAS, which we'll talk about some more. So all of these chemicals might either mimic the effects of iodine deficiency, inadequate iodine in the diet, or perhaps exacerbate it where it already exists. Then there are a number of chemicals that we know inhibit thyroperoxidase, which is an enzyme that is needed, again, for thyroid hormone production in the thyroid gland. So if there's inhibition of thyroperoxidase, again, that will decrease the amount of thyroid hormone that can be produced. So some classes of chemicals that can do this are isoflavones, which are found, for example, in soy, pesticides, and PFAS again. A number of chemicals can alter binding of thyroid hormone to proteins in the blood. These may not matter so much in most individuals because we have sort of homeostatic systems that can compensate. We have feedback systems, and so if binding proteins go up or down, that may actually not have huge health implications, but it may matter in some settings. And some of the chemicals that can do this, it's kind of an alphabet soup. PBDEs, they're flame retardants, PCBs, which are mostly phased out of production, PFAS, phthalates, which are plasticizers. Some of the chemicals that can activate thyroid hormone metabolism, so particularly in the liver, will increase the rate of degradation of thyroid hormone, which might decrease circulating hormone that's available. Some chemicals that can do this are some pesticides, PBDEs, and dioxins. And then finally, at the level of the cells that are responsive to thyroid hormone, where thyroid hormone has its action, there are a number of possible targets. So bisphenol A, which is found, for example, in some plastics, may inhibit transport of thyroid hormone into the cells where it has its action, so prevent it from getting to its target. A number of chemicals, including BPA, PBDEs, PCBs, PFAS, phthalates, triclosan, may alter deiodinase activity. And deiodinases are the enzymes specifically that convert T4, which is kind of a circulating prohormone, to T3, which is the active form of thyroid hormone. And then finally, there are a number of chemicals, BPA, PBDEs, PCBs, phthalates, PFAS, triclosan, that may act at the level of the thyroid hormone receptor in cells and turn those receptors on or off, kind of irrespective of the amount of circulating hormone. So honing in a little bit more, looking specifically at PFAS, because this is one, at least in the US, that's been in the news quite a lot recently. This is not a single chemical. It's a whole group of maybe thousands, in fact, of different chemicals. They are technically pair and polyfluoral alkyl substances. And these are synthetic compounds that have been used in industry quite widely since the 1940s. And they are widely used because they have a lot of very appealing properties. They're water soluble, they're colorless and odorless and tasteless. They have non-stick and surface tension lowering properties. So they're useful, for example, as stain repellents on furniture or clothing or carpets. And they're also useful, for example, in non-stick cookware. They're used in consumer products like cookware. They're used in food packaging. And they're also a major ingredient in aqueous film forming foams. So things used by firefighting as part of firefighting. So these tend to be widely used in military bases and airports, and there has been a fair amount of contamination of water supplies specifically related to use of these firefighting foams. Overall, these can get directly into the food supply. For example, when they're used in food packaging, they can get into the soil and into groundwater, so therefore into drinking water supplies, and they can then find their way into food, for example, in seafood. Now, this is a pretty widespread problem. This is a US map, the most recent one I could find, showing sites of known PFAS drinking water contamination. And you can see that this is really pretty much spread across the country, with a whole lot in the northeast of the country, which is where I am. But this is not a US problem. Most countries that have looked for PFAS in drinking water have found it. So this is a map I found from the Royal Society for Chemistry, looking at known PFAS exposure in UK drinking water. And you can see, again, that there's pretty widespread exposure across the country. So there are multiple adverse health effects that seem to be related to exposure to PFAS chemicals. So endocrine disruption is only one of these. And these seem to have broad impacts throughout the body, partially because they can mimic fatty acids, which will then have effects sort of across a number of different organ systems. So PFAS exposure has been linked to adverse effects on reproduction, like decreased fertility, higher levels of hypertension and pregnancy. It's been linked to some cancers, including prostate, kidney, and testicular cancer. It has been shown to impair the immune response, including perhaps decreased responsiveness to vaccines. This may be something that increases cholesterol and may increase risk for obesity. There are developmental effects in children, so low birth weight, accelerated puberty, perhaps behavioral changes, and then again, endocrine disruption, specifically, as we've noted already, thyroid disruption at probably a lot of different levels in the thyroid hormone axis. When we look specifically at thyroidal effects of PFAS, the data get a little bit complicated, and we see somewhat different effects across studies. So in animal models, we see some models where PFAS exposure seems to increase thyroid hormone, but other systems where it seems to decrease thyroid hormone. In the cell and the test tube, we know that these chemicals do actually accumulate in thyroid cells. They may be directly toxic to those cells, but some of those mechanisms I've discussed already within the thyroid cells, they may reduce the thyroperoxidase activity. They may inhibit iodine uptake, so decrease iodine utilization by the thyroid. And they may, again, also at the level of receptors, interfere with thyroid hormone action. When we look in epidemiologic studies, again, the data are mixed. And when we look in pregnancy, specifically in epidemiologic studies, the data are mixed. But I think there is sort of a growing body of evidence that does suggest that at least for some of these PFAS chemicals and for some life stages, they may decrease thyroid hormone production and decrease thyroid hormone action. Some of the science gets complicated because some of these effects may be species specific, they may be life stage specific, and you may, for some of these chemicals, as I'll show you, see different directionality of effects at different doses or different effects for different PFAS chemicals. I want to highlight one study that we did recently in the Boston area in a pregnancy cohort, specifically looking at exposure to 6 of sort of commonly encountered PFAS chemicals in relation to maternal and infant thyroid function. And the first thing we saw, which has been seen in a lot of studies, is that often people who have exposure to one of these chemicals are highly exposed to other chemicals in the same group. So these tend to be exposures that cluster in specific individuals. And the methodology for assessing the effects on hormones of groups of chemicals is a little bit complicated. So bear with me here. But basically, using what are called weighted quantile sum regression models, we effectively looked at the effects of a group of these 6 PFAS chemicals on thyroid hormone levels that were circulating in pregnant women. And what we saw was that this exposure to this group of chemicals seemed to decrease circulating free thyroid hormone, free T4. And we know that lower free T4, because it's so important for the brain development of a fetus, may impact brain development in early life. Looking in the same cohort at the same group of chemicals, we also saw that exposure to this group of chemicals was associated with lower thyroid hormone levels in the newborn, again, raising concerns for potential effect on developing brain. In the same cohort, we looked at these same exposures and outcomes using a different type of model, this one called Bayesian kernel machine regression, which really allowed us to sort of separate out not just the whole mixture's effects on thyroid function, but the effects of the individual chemicals. And here it just gets more complicated because we saw different effects for the different chemicals. One of these was associated with increased thyroid hormone, one with decreased thyroid hormone in pregnancy, and one you see here, panel C, sort of a U-shaped nonlinear effect on thyroid, on TSH in pregnant women. And this is kind of a hallmark of a lot of these endocrine disrupting chemicals, is they may not have linear dose responses. So for some of these chemicals, you may see effects in one direction at one dose, but in a different direction at other doses, which makes the science that much more complex. And again, in the infants, again, we saw different effects of different chemicals within this group that we looked at on thyroid function. So as a group, this group of chemicals, PFAS chemicals we looked like was potentially having adverse effects on thyroid hormone at a very sensitive developmental stage. But of course, this is one small study. Looking more broadly at a meta-analysis that pooled data from 13 different studies in about 8,300 pregnant women in different parts of the world, and looking just separately at each of these 6 PFAS chemicals, or I guess 5 PFAS chemicals in this group. Again, they saw somewhat different effects of different chemicals in this analysis, but some of these seem to be associated with higher TSH, therefore suggesting sort of slightly diminished thyroid function in pregnancy. Now, this has been in the news in the US because just about 2 weeks ago, the United States Environmental Protection Agency has announced fairly stringent new regulation of drinking water supplies in the United States, so that by 2027, for 6 of these PFAS chemicals, most of the ones I just showed you in those analyses, there's going to be required monitoring of all public water systems for levels of these chemicals. And by 2029, any water supplies where these chemicals are exceeding fairly stringent limits are going to have to take steps to mitigate this exposure. Now, it's important to note that this is not being implemented specifically because of what we know about thyroidal effects of PFAS exposure. I've told you there's probably good evidence to suggest that PFAS is a thyroidal disruptor, but not really necessarily perfect agreement on exactly what it's doing in all individuals. But this is really based on the fact that PFAS seem to have widespread adverse health consequences, not just effects on the thyroid. So that's what's happening with regulation for PFAS in the US. Things are different around the globe. In Europe, I think Europe has been ahead of the US by and large in terms of regulations around exposures to a number of these endocrine disruptors. UK perhaps has been a little bit behind. And again, this is coming from the Royal Society of Chemistry, suggesting that current UK standards for PFAS in drinking water really would allow concentrations that are far higher than what is currently acceptable in Europe and what has just been regulated in the United States. So what does this all mean? We have this growing body of evidence suggesting that there's rather a vast group of chemicals that may have these adverse effects on endocrine systems. But I think what we know is really dwarfed right now by what we don't know. What we know is the tip of the proverbial iceberg, and a lot more science is probably needed. The Endocrine Society in the US published a white paper on this in 2015. And at that time, they noted that there are in the US alone, nearly 85,000 different chemical substances that are sort of indexed as being manufactured by industry in the United States. And that's probably not a complete list of all the chemicals that are out there because it excludes things that were new or were sort of proprietary formulations. I've seen estimates as high as about 350,000 for all the chemicals that we may be exposed to kind of as a global society. So the problem is huge because there are an enormous number of chemicals that might need to be tested. Historically, testing for adverse health effects of these chemicals was done in animal models. Could only test one compound in a few doses at a time, and these models sort of really looked for linear dose responses. So sort of assuming that you have more adverse effects at higher doses, which may not be true for some of these endocrine disruptors. So at the US EPA and other regulatory agencies are really trying more recently to look at non-targeted approaches where we can sort of screen large numbers of chemicals for potential concern and therefore hone in on the chemicals that really need more study. An example of that is this study published in 2019. Here they screened 768 different chemicals to look for ones that blocked sodium iodide synthetase, so the ones that block the uptake of iodine into the thyroid gland. And they identified more than 20 that were pretty potent inhibitors, some of which were known, like PFAS, chemicals like perchlorate, which I talked about earlier, but some of which had not been known previously. And this then allows context for some additional studies. The Endocrine Society noted in its white paper that specifically with regard to thyroid hormone disruption, there are three key areas of research, and I think I would agree that these may still be the three key issues today. One is just understanding how we can do high throughput assays to predict thyroidal disruption, because again, measuring a handful of chemicals in a handful of models at a time is not going to get us where we need to be. We also need better methods for understanding additive or synergistic effects of being exposed to whole groups of chemicals, because none of us is exposed to one of these things in isolation. We're all sort of exposed to a whole soup of these chemicals which might act together at the thyroid or at other endocrine systems. And then finally, I think of great concern are the thyroidal disruptors that may turn on or turn off thyroid receptors regardless of the actual presence of thyroid hormone. Things that shift the amount of circulating thyroid hormone we can test for. These are tests that we use routinely in clinical care. But things that turn on or off the receptor without affecting the amount of circulating hormone in the body are much harder to assess. And I don't think we yet have good ways to do that. Now, as a clinician, we have very limited data for what we should be doing in the setting of a specific patient in a specific visit. The National Academies of Science in the US published some guidance on PFAS exposure testing and clinical follow-up in 2022. And among lots of other advice for lots of other potential health effects, it suggested that people with the known highest exposures to PFAS probably should have annual TSH testing to exclude hypothyroidism. The problem with this is that although PFAS can be tested for, those tests are not widely available in the clinical setting. In my setting, they wouldn't be covered by health insurance. And so most people who have these exposures probably aren't going to know it. I think what at the moment is probably more useful is general advice about how to avoid some of these exposures in the first place. And this is advice for patients, for families, for the general public. Much of this is kind of common sense stuff. So one is, wash fruits and vegetables carefully, try to buy organic because we, less exposure to pesticides, but be aware that not everybody has the resources to pay more for organic produce. And this might be a place where we see exacerbation of healthcare disparities based on socioeconomic status. We want to avoid the use of pesticides in our own gardens. When we bring new things into the household, kitchen equipments, clothing, sheets, towels, we want to wash them before first use, gets rid of some of these coatings. Generally a good idea to avoid air fresheners and fragrances and to limit the use of cosmetic products that include phthalates and parabens. One of the tips on the slide is to ventilate your home for 10 minutes a couple times a day. I live in Boston. It gets really cold here in the winter. This is really not practical advice, but in parts of the world and at seasons of the year where it makes sense, that's not a bad idea. Dusting, just keeping the house free of dust that accumulates on surfaces can reduce exposure to these chemicals. We know from a lot of studies that these endocrine disrupting chemicals do seem to accumulate in household dust, and levels in household dust does seem to be associated with adverse health outcomes. And then finally, we want to try and avoid sort of plasticizers seeping into foods we eat. In particular, want to avoid reheating food in plastic containers. There's more advice at the Endocrine Society website that you can look at. Some additional things are to use glass, porcelain, stainless steel containers for storing food when you can. If you don't know about the safety of your water supply, consider using water filters, replace older nonstick pans with newer ceramic ones. And probably good advice in general for all of us for lots of reasons is to eat a diversified diet with plenty of variety. Hand washing may be helpful. Minimizing handling of receipts because those receipts from shops contain BPA. It says avoid outdoor exercise when air pollution levels are high. And again, it depends on where you live in the world. This may or may not be feasible. Avoid hand-me-down plastic toys because some of the older plastics contain more of these endocrine disrupting chemicals. Certainly look for infant formula bottles and other water bottles that are labeled BPA free. But an important note is that for some of these plasticizers, things that the public has sort of grown to realize may have adverse health effects like BPA have been replaced in many cases by other plastics, which may or may not be safer. They're probably just less studied. Important to note that specifically for endocrine disruptors that interfere with iodine utilization, that having optimal iodine nutrition may mitigate impact a bit. And we should all be looking for optimal iodine nutrition anyway. Across societies, iodine deficiency is associated with adverse effects on brain development. So in the US and in Europe, currently there are recommendations that women who are planning pregnancy or pregnant or breastfeeding should take a daily iodine-containing supplement. And again, that won't mitigate risk for all these different types of disruptors, but it will mitigate risk for some of them. So I will conclude by noting that exposure to known thyroidal endocrine disruptors is really ubiquitous. We're all being exposed to the ones we know about, but probably there are a lot of additional thyroidal disruptors that we're exposed to that we just haven't studied yet. We need more science, so we need to better understand additive and synergistic effects of all these mixtures of chemicals, effects at different life stages, and effects at different exposure levels. Specifically with regard to thyroidal disruption, I worry most about adverse effects when the exposure is in early life and pregnancy or in young children because of the importance of optimal thyroid hormone for the developing brain. And finally, some common sense precautions can reduce some exposures, but really for most of this, we're going to need regulation by governments of manufacturing and drinking water content to really reduce exposures to these chemicals for all of us. So with that, I thank you for your attention. I think we have some time for questions.
Thank you very much indeed, Elizabeth. That was a superb overview of the problem of endocrine disrupting chemicals. And I know that we'll have many, many questions. In fact, I can see them coming in. But I'm going to take advantage of the fact that I've got the microphone and I'm going to ask you, I mean, you made the comment that it would not be possible to measure endocrine disrupting chemicals as a routine part of managing an individual who comes into your practice. But have there been any studies to measure these endocrine disrupting chemicals in people? I mean, you commented the huge amount of exposure that we get, but do we know that they actually are in our systems?
We do. In the US, where I practice and study, NHANES, which is sort of a nationally representative survey, has blood and urine data for a lot of these exposures. And it's shocking how many of them are truly ubiquitous, are seen, in virtually everybody who's studied. So yes, they definitely get into humans. We can measure them. It's possible to measure them for epidemiologic studies. What we don't really have right now is sort of a panel of endocrine disrupting tests that have clinical application in most settings. They're not either available or not paid for by health insurance systems.
Okay, and related to that, there's a question from our audience. Do we have any kind of idea of how long these endocrine disruptors can actually stay in the system? Or is it just that they're being replaced constantly, so they're always there?
It depends on which disruptor we're talking about. Some of these are, including PFAS and PCBs, for example, are what are known as forever chemicals, meaning once they get into the environment, they are very stable and they are kind of going to be there indefinitely if nothing is done to mitigate. In the body, some of these disruptors will tend to accumulate over time. So sort of the longer you live, the more they accumulate in the body. Some of these are more transient exposures. And so it depends a little bit on which of these disruptors we're talking about.
Okay, and then another question from our audience. Are there any specific chemical names that people can look out for so that they know, on foods, on beauty products, cleaning products, all of these things that you've mentioned to us, things that can heighten our awareness so that we know to try and avoid things, or is it impossible to avoid them?
It's a little, well, it's probably impossible at this point to avoid everything. No matter, how vigilant you are about kind of policing what you're buying and bringing into the household. I think avoiding things that have added fragrances is a good idea. I think for some cosmetic type products, you can look at ingredients and see phthalates, you can see parabens, you can see triclosan in ingredient lists. But frankly, I'm not a chemist, and reading labels of some cosmetics, it's not for the faint of heart, and it's not for most of us who aren't really expert in the field. So it can be hard to decipher what's really in those things.
Sure. And I mean, I don't know whether you might be able to perhaps just jot a few of these names down, and we can then circulate the names to our membership afterwards, if that would be possible.
Sure.
And then that would be kind, thank you. So would water in glass bottles be more beneficial than water filters?
Possibly, yeah. And
Okay,
by and large, reducing exposure to foods, drinks that are stored in plastic is good. Probably just
okay.
for the environment in general, reducing plastic is good.
And okay, and related to that was something that I noticed in the map that you showed of the United Kingdom, where there were areas with PFAs at high concentration in the drinking water. Often that was associated with cities, which is what you would expect, where you've got large numbers of people. But I was then reflecting that many of our water storage and collection actually happens out in the countryside. So it's slightly surprising that, or even more worrying, if you like, that our water supplies are so compromised when you think of where they are collected, because it's, in Wales, it's the Brecon Beacons, which is a national park. So any thoughts on that?
Again, these are forever chemicals. So that once they get into the soil and seep into the groundwater, they're going to be there kind of in the aquifer and maybe over fairly wide territories. I'm not an environmental scientist, so I'm probably not an expert on how this gets into the environment so much. But I think probably this is becoming pretty widespread in water supplies. And those maps show the ones where we know there's exposure, but certainly there may be places where we don't have measurement yet.
Of course, of course. And now a straightforward question in some ways, but one of our participants says, okay, I don't have a thyroid, so how is it going to affect my thyroid? And I know you've touched on this a little bit, but is there anything specific that would be applicable to someone who's had a thyroidectomy in the context of endocrine disruptors?
So I guess the good news about having had a thyroidectomy is your thyroid is no longer susceptible to influence by endocrine disruptors. You might still be susceptible to changes in protein binding in the circulation of thyroid hormone, which could necessitate sort of increases or decreases in dosing of your thyroid hormone replacement. could be susceptible to endocrine disruptors that increase thyroid hormone metabolism, which again might necessitate increasing doses to keep levels stable. And a pregnant person who doesn't have a thyroid, is going to give birth to a fetus who does, and who still could have some susceptibility once the fetal thyroid is working in the second half of pregnancy. So there is some protection, but perhaps not complete protection against these effects.
Incredible, incredible. I mean, obviously, these chemicals cross the placenta.
Yes, sadly,
Yeah.
and they get into
Yeah,
breast.
sadly.
Yeah.
Yeah. And then we have another question related to this idea of the impact on fertility. And you mentioned differences in sex ratio, numbers of offspring, fetal size. Could you give us a little bit more information about those specific effects in the pregnant woman and in her fetus?
Okay, and here's where I'm sort of limited by the fact that I'm a thyroid endocrinologist, and I'm not a reproductive endocrinologist. So I don't know the ramifications of, for example, the sex ratio very well. Certainly, thyroid hormone hypothyroidism in pregnancy linked to alterations in child birth weight, so both large and small for birth weight babies, kind of depending on what the perturbation is in the system. Also has been linked to higher rates of pregnancy-induced hypertension. So those are just specific to thyroid disruption. And a little bit of data, it's hard to study fertility. So it's hard to study what's sometimes called fecundability, which is the likelihood of getting pregnant when you're trying, because you sort of need to enroll large groups of people who aren't pregnant yet, and those are sort of hard people to enroll in studies. But some evidence that perhaps some of these disruptors are associated with reduced fecundability. Some of that could be, related to thyroidal disruption, because you need sort of optimal thyroid function for optimal fertility. But some of it also probably to reproductive hormone disruption. And again, because these can all be affected in so many different ways, the problem gets a little bit complex.
Sure. And sort of staying in the with the neonate, a little bit closer to the thyroid now, congenital hypothyroidism, and I'm sure many of the people listening will be aware that this is one of the conditions that we test for in the UK, and indeed many, many countries worldwide, and it's the little heel prick that children have. And I know from experience and from talking with other people that we really know very little about the genes responsible for congenital hypothyroidism. So do you think that the missing cases could be due to epigenetic modification because of these disruptors?
Certainly possible. And certainly, we know the genetics of some forms of congenital hypothyroidism, but not all cases we can't identify a genetic cause in all cases, and we're still learning more about the genetics of that disorder. Might also be worth noting that throughout life, there may be genetic differences that affect that will alter the effects that these chemicals will have on us, that some of us may be relatively protected or relatively more at risk due to our underlying genetics. So an example of that is that, 10 or 12% of the population probably have, mutations in the gene for the deiodinases that convert the precursor hormone T4 to the active hormone T3. And there's sort of a suggestion that perhaps those individuals might be those who feel less well with thyroid hormone replacement, but also a suggestion that those individuals might be particularly susceptible to some of these environmental disruptors if there's less ability to activate hormone, or some of these environmental disruptors are known to alter those deiodinase systems, and perhaps some individuals with these mutations might be more susceptible to that kind of disruption.
Interesting, very interesting. And I know that I was very interested in the comments you made about ADHD. And I think that globally, there's been quite an increase in the number of people of all ages being diagnosed with ADHD. And one of our participants would like a little bit more information. If you have any more, you can tell us about EDCs and the cognitive problems.
Yeah, so there are a lot of epidemiologic studies that have linked EDCs to higher rates of attention deficit hyperactivity disorder. PFAS are among those. And this is, again, probably complicated because there are probably a lot of different impacts on the developing brain that can increase susceptibility. And some of the epidemiology is tricky because we are probably diagnosing this more because we have better tools and more knowledge about the need to diagnose than we did decades ago. So it's hard to really gauge what are true trends in increasing incidence of this disorder over time, and what's just our better ability to diagnose it and identify it. Certainly within the thyroid realm, iodine deficiency has been linked to attention deficit hyperactivity disorder, as well as possibly to higher rates for autism spectrum disorder. And we know that the developing brain has a lot of inputs, an enormous number of inputs, which makes this hard to study, nutrition and environmental disruption and genetics and all kinds of environmental inputs that could increase or decrease risk for these things. So the studies are, by definition, it's a little bit hard sometimes to really narrow down on cause and effect. But I showed you the slide that attention deficit hyperactivity disorder, lower IQ, seems to be the biggest sort of financial hit from these endocrine disruptors in most analyses, and it probably is substantial. And certainly we have over recent decades had increasing exposure to these chemicals. At the same time, we've seen increasing rates of ADHD, which again may have multiple reasons. But I think there is good evidence from epidemiologic studies that environmental disruption may increase that risk. And the exact mechanisms, I think we don't really know.
Okay, thank you. And a very interesting point being raised here. What should we all be doing to try and encourage our governments to take these issues a lot more seriously? And I noticed that some of the white papers that you referred to were an author was Gore. Was that the Gore? The Al Gore, or is it not?
It's not. No, it's a thyroidal disruption.
Okay, because I mean, I know he's very big in the whole environmental issue, isn't he?
Yes, but I think, just having a voice, that all of us as individual constituents can have a voice here, and that can be powerful. So when I think people in government hear that this is an issue that we all care about, that drives it to the top of agendas, and that, drives legislation and regulation and measuring and all the things that I think are really ultimately going to have to happen at a pretty high level to protect all of us from these exposures.
This is very much the case. And I mean, you commented that PFAs have been very much in the news recently in the US, and very much the case here. And I know when we were chatting a couple of weeks ago, I made the comment that another thing that we hear a lot about is microparticles and microplastics rather, and nanoplastics. And from what I can see, it seems as if these may be a medium for introducing some of these endocrine disruptors into our systems as well. And I wonder if you have any further insight or any other comment about microparticles, because I mean, things like the wipes that we use to take makeup off, for example, they contain large amounts of them. So they are also just everywhere.
Yeah, I think it's another potentially somewhat ubiquitous exposure. I don't think there's a lot of data yet specifically looking at thyroidal disruption, but I think there's data looking at disruption of other hormone systems related to some of those exposures. And something I alluded to briefly is air, microparticles in the air too, so air pollution. It's sort of astonishing. I wouldn't have predicted this, but also, clearly an endocrine disruptor, a thyroidal disruptor, among others. So routes of inhalation to these tiny, tiny particles in water, in food, in things that we're applying to our skin, in the air we breathe, it's kind of everywhere.
It is indeed everywhere. And then we have a question which is not specifically about endocrine disruptors, but does relate to something that you've commented on. And it's possible that John might also have some comment. And that's that individuals who are on thyroid hormone replacement sometimes find that the messaging around iodine can be a little bit confusing. So I wonder whether you could perhaps just explain if you have no thyroid, or if you have an underactive thyroid and you're taking thyroxine, what you should and shouldn't do about iodine. And maybe, as I say, afterwards, maybe John would like to say something about that as well.
Sure, John, absolutely feel free to jump in. You know this very well. But the only known use of iodine in the body is in making thyroid hormone. So that's what it does. It's an important use, but that's all it does. If you don't have a thyroid anymore to make thyroid hormone, if you've had a thyroidectomy, it probably doesn't really matter how much iodine you're ingesting because you're not making your own thyroid hormone anyway. If you are a pregnant individual who's had a thyroidectomy, and again, the fetus has a thyroid that needs its own iodine supply in the second half of pregnancy, there is iodine that gets metabolized from the thyroid hormone that's ingested. So I'm not sure it's really critically important in most cases for pregnant individuals, specifically who are taking full thyroid hormone replacement, to necessarily get that iodine in the diet. Altering iodine intakes will shift thyroid function. People with some underlying thyroid compromise can be particularly susceptible to developing either iodine-induced hyperthyroidism or iodine-induced hypothyroidism, particularly with high iodine doses, which probably should be largely avoided. So the amount of iodine that's really required for thyroid hormone production is in the microgram range, 150 micrograms a day if you're in a non-pregnant adult, and maybe 250 micrograms a day if you're pregnant. And exceeding that by a large factor actually increases the risk for thyroid dysfunction. John, you want to maybe chime in and add to that?
Only that people should be aware that they should try and monitor, look carefully at the amount of iodine they're taking in, and because the information is not obvious in many cases. So if they've got any problem, they should excuse me, they should act on that and try and get some more information. I mean, as you point out, it's a huge, complex business. So I think it's probably at the end of the line for many people who don't know much about iodine, but they should perhaps consider that under any circumstances, too much or too little may be a problem.
Perfect. As for most nutrients, too little is not a good thing, and it's probably still the world's leading cause of preventable brain damage, but too much is not a good thing either. So there's a sweet spot in the middle.
Yeah.
And I know John has been working very hard to try and get the salt in the UK iodized at a sensible level, but that has been an uphill battle, sometimes won and sometimes less so. So yeah, still work to be done there. Now, I think we seem to have addressed most of the questions that have come in through our question and answer session. So if anyone has any further burning questions, please get your questions in as soon as possible, because otherwise I think we're going to be thinking about moving on. So Julia, is there something that you would like to say at this point?
I think, well, thank you. Thank you so much, Elizabeth, for your really fascinating and insightful talk. And you covered so much with it. There was a lot of science there, but also lots of practical stuff as well. I think it's particularly useful for us will be the list from the Endocrine Society of guidance and steps that people can take to look after to avoid endocrine disrupting chemicals. So I think I'll try to get hold of these and we can share them on our website and create an article that people can access in the future. And I was also really interested to know what you said about the question about what we can all do to encourage our governments to take things more seriously. Because I think as individuals, we can often feel overwhelmed and really quite helpless in the face of all this. But I guess that's why the European Hormone Day movements like this are so important, because they encourage us to work together internationally with and the endocrine societies throughout the whole of Europe are working together to see if they can influence policies to make a difference at a higher level, but to get patients and the public involved too. So it really is at every level of society that we all need to get involved to show our governments that we do care about these things, and they might be complicated things to make policies on, but actually they're very important and they really make a difference to everybody's lives. Thank you very much, Maren, for the questions that you picked out from the chat. And I'd really like to say a very special thank you for John for being here. If people on the call don't know John is a patron of the BTF. He's been a great champion and supporter of the British Thyroid Foundation from the time it was started in the early 90s. And he's worked with Elizabeth over the years in thyroid research, and particularly about iodine and pregnancy. And so we're absolutely delighted that he was able to join us today, and to introduce Elizabeth and to be involved as well. The questions covered a variety of topics. I'm really glad and grateful to all the people who put the questions into the chat, because we all learnt as a result of your questions. If you've got other questions that you think of after the event, send them in to us and we'll do our best to answer them in some way. If you joined late or you'd like to go back and listen to any bits of the talk again, this recording of the webinar will be on our YouTube channel and on our website after probably from tomorrow, so you can join that. We're at the BTF is a small charity. I can share the slide so you can get the details for the future. The BTF is a small charity, and we rely on fundraising and donations from the people who join our events. So if you would like to make a donation to enable us to carry on with events and put on events like this in the future, we'd be very, very grateful for that. There will also be a feedback form that comes out after the meeting, so please feel free to give us any feedback and suggestions about future topics you'd like us to cover. And finally, also a reminder that our next webinar will be in a few weeks' time about thyroid surgery. So if any of you would like to join us for that, we have a endocrine surgeon who will be talking, but also one of our trustees who's a thyroid patient has recently had thyroid surgery himself. So that will be a really fascinating insight into surgery from the patient and doctor perspective as well. So thank you very much to everybody. Thank you very much to Elizabeth for giving up your time today, all those miles away. We really, really value you being able to join one of our events in this way. I feel really, truly honoured. And thank you to Marion for so expertly chairing and encouraging the discussion in the meeting, and also for John for joining us as well. Please join us in the future for any of our future events. And if you'd like to follow us, you can go to our website and follow us on social media, and you'll be able to follow all the work we do that way as well. Thank you very much, and good night.